For years, we've chased a dream of stepping into digital worlds so vivid, so responsive, that we forget they aren't real. But every time we get close, something breaks the illusion. Blur, lag, motion sickness. A world struggling to keep up with us. What if the problem isn't the headset, or the graphics, or even the internet speed? What if the problem is the way we stream reality itself? What if I told you that a revolutionary approach to 3D streaming is about to change all of that? Today, you're going to discover the breakthrough that could finally make VR and AR feel real. Here's something nobody tells you. VR and AR try to run on a system designed for flat screens, a system built for 2D. Everything we watch online, movies, games, live streams, is compressed into a two-dimensional image. Predictable, linear, simple. But VR and AR, they're alive. They move with you. They depend on your eyes, your head, your motion, every millisecond. So every time you turn, your system tries to redraw an entire world instantly. Millions of polygons, lighting, shadows, physics. Your network can't send that fast enough. Your headset can't compute it fast enough. So you get lag, stutter, that strange, floating feeling. This isn't a device problem. It's a pipeline problem. And solving it required a completely different way of thinking. A group of engineers asked a radical question. What if we stop streaming images and start streaming space? Instead of sending frames, like watching a video, they send volumetric data, the structure of the world itself, not the paint, the blueprint. We realized we could treat a virtual world like a living organism, only stream the parts the user interacts with, nothing more. This idea led to adaptive 3D streaming, a technology that streams neural point clouds instead of full scenes, predicts user movement using micro-motion patterns, rebuilds objects on the fly, renders only what your eyes actually see, offloads heavy work to edge computing nearby. In simple terms, instead of downloading a world, your headset receives the DNA of the world, then grows it around you. Worlds don't load anymore. They materialize. Here's how it works in real time. Your eyes move. The system predicts where you're going to look next. It streams only the 3D data needed for that area. Edge servers finish the heavy lifting milliseconds before you even get there. Your device renders a final layer. Crisp, stable, perfect. It's like Google Maps, but instead of loading streets, it loads reality. And all of it happens faster than you can blink. When early testers tried it, the reaction was the same: silence, then disbelief. When the tester moved his head, the world didn't drag behind. It anticipated him. It felt alive to the tester. Another tester described it as, the first time VR didn't feel like VR. The world felt present, not rendered. Present, that's the difference. A surgeon practicing with zero latency. Students walking inside a digital Roman city. Architects pulling apart a holographic building. A virtual concert with millions attending simultaneously. With this new pipeline, even massive virtual environments can feel effortless. Your headset doesn't struggle. Your network doesn't choke. Your brain stops noticing the barriers. For the first time, the illusion holds. If this technology scales, and it's already showing signs that it can, everything changes. The fundamental challenge with streaming immersive content has always been a massive amount of data required, explained Yong Liu, professor in the Electrical and Computer Engineering Department, ISE, at NYU Tandon and faculty member at both NYU Tandon Center for Advanced Technology in Telecommunications CAT and NYU Wireless, who led the research team. Traditional video streaming sends everything within a frame. This new approach is more like having your eyes follow you around a room. It only processes what you're actually looking at. The technology addresses a field of view FOV challenge for immersive experiences. Current AR/VR applications demand high bandwidth. A point cloud video, which renders 3D scenes as collections of data points in space, consisting of 1 million points per frame, requires more than 120 megabits per second, nearly 10 times the bandwidth of standard high-definition video. Unlike traditional approaches that first predict where a user will look and then calculate what's visible, This new method directly predicts content visibility in the 3D scene. By avoiding this two-step process, the approach reduces error accumulation and improves prediction accuracy. The system divides 3D space into cells and treats each cell as a node in a graph network. It uses transformer-based graph neural networks to capture spatial relationships between neighboring cells and recurrent neural networks to analyze how visibility patterns evolve over time. For pre-recorded virtual reality experiences, the system can predict what will be visible for a user 2 to 5 seconds ahead, a significant improvement over previous systems that could only accurately predict a user's FOV a fraction of a second ahead. What makes this work particularly interesting is the time horizon, said Liu. Previous systems could only accurately predict what a user would see a fraction of a second ahead. This team has extended that. The research team's approach reduces prediction errors by up to 50% compared to existing methods for long-term predictions, while maintaining real-time performance of more than 30 frames per second, even for point cloud videos with over 1 million points. For consumers, this could mean more responsive AR/VR experiences with reduced data usage, while developers can create more complex environments without requiring ultra-fast internet connections. We're standing at the edge of a shift as big as a jump from radio to television or from desktop to mobile, a shift from a flat internet to a spatial internet. And adaptive 3D streaming might be the key that unlocks it, because when your world responds as fast as you do, it stops feeling like technology. It starts feeling like reality. If you're ready to explore the breakthroughs shaping the future of immersive technology, subscribe, because what's coming next won't just change your screen. It'll change your world. We spent decades imagining the future of VR and AR, but maybe the future was never about the hardware. Maybe it was about how we stream reality itself. And today, that future finally feels within reach. If you want to stay ahead of this revolution, hit subscribe, because the world you're standing in might not be the only one you visit today.